Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Mazli, one of the members of this group, and today we're going to talk about the fundamentals of logic for our math group project. Now, the introduction to this topic. Today we're talking about logic. Of course, it's fundamentals of logic. So, what is logic? Logic deals with methods of reasoning and thinking in a systematic way which provides foundation for mathematical reasoning. It is also beneficial because it helps us prove whether an argument made is true or false. And this presentation is made to answer certain questions from this topic to enable us to easily understand how logic works and how we can use it in our daily lives. Now we're going to talk about description. So, there are 5 subtopics for this particular topic, which are statements and logical connectivities, truth tables, logical equivalences, laws of logic, and arguments. Okay, I'm going to start off with the first one, statements and logical connectivities. What is a statement? A statement or proposition is a declarative sentence that is either true or false and not both. And then we have logical connectivities, which are logical operators which are going to be used in the whole topic here. So we have upside down V or conjunction, which is called considered an and. We have the V, which is called disjunction, and it is considered an or. We have a squiggly line. It is considered negation or not. We have an arrow going through. Yeah, that is a conditional statement. Yeah, conditional operator. So it defines whether it is it defines the statement as an if statement. And then we have the biconditional statement, which is defines the statement as if and only if. Okay. Next we have truth tables. Okay, truth tables are usually used to show the truth values of the compound statement or propositions. Given that truth values of propositions from which they are constructed, this means we basically make a table and display out each and every single truth value there is, and then we compare it to each other if we want. Now we talk about logical equivalences. Okay, logical equivalences is usually a method we use to see if one statement has the same true value as the other statement. And we also have 3 conditional propositions, which are inverse, converse, and contrapositive methods to determine whether or not we have 3 conditional propositions, so inverse, converse, and contrapositive, which can form other types of statements. Yes. Okay, now I'm going to talk about laws of logic. Laws of logic is for any, they have equivalent identities for any primary propositions P, Q, and R, and any tautologies T, and any contradictions C. We have the following equivalent identities, which is this table over here. See, we have that here are the list of laws that we usually use in the questions that we answer for this topic. Okay, and then finally we have arguments. Okay, I'm not really going to talk about arguments so much because I'm going to explain it in question number 2. So moving on.
Hello and Assalamualaikum. So my name is Muhammad Iqbal Hakimi bin Muhammad Nizam, and for this part I will be presenting about question 1 of problem 4. So here is the question, where it states that we need to construct a truth table to determine whether the expression of P or Q implying R logically implies the expression P implies R and Q implies R. So in this part, there are 2 subtopics used in fundamental of logic, where the first is statements and logical connectives. We are going to use the logical connectives where the question contains of imply and or. So there are three connectives here, and next we need to make a truth table, where the truth table we need to state whether the truth table is either tautology, contradiction, or contingency. So next we need to solve the question, where firstly, to solve this type of question, there are 4 steps needed to solve it. So the first step is that we need to identify the variables, and we can see is that inside the question there are 3 variables, which is P, Q, R. For the 3 variables, it is needed to make the truth table. To make the truth table, we need to decide whether the truth table size is fit with the variables. So we need to make 8 boxes for the truth table containing the 3 variables. And next, we need to state the connectivities of the variables. So here is the truth table containing all of the variables as well as the connectivities on the top. After stating all of these 3, we need to state the truth values. So to state the truth values, there are actually patterns in solving this question. So for an 8 box of truth table, the pattern would be having 4 truths and 4 false. Next, we have the 2 truths, 2 false, 2 truths and 2 false. Next, 2 false, 2 false, 2 false, 2 false. So after doing that, we need to solve for every component the question's components to values. So in here is that P or Q for an OR connectivity. Since it is an OR, one of the variables is needed to be true in order to the statement to be true. So in here, from box 1 to box 6, it is true because all of them contains 2. But 7 and 8 does not contain 2, which means it will be false. So the second part is that we need to compare between this one and R. And the connectivity will be the imply. So for imply, if the first statement of P or Q implies R, where both of them are true, it will become true. But since this one will be implying R and true becomes false, it will become false. And it will repeat for every part until the end. So here we can see is that it becomes true because true is true. It will become false because true becomes false, as it implies R, where R contains true value of false. And both are the same. True and false becomes false. False and true, it will become true because implying R. And false becomes true because both of them are the same true values, implying each other. Next, we need to do the second expression, where the second expression says that P implies R for the first part, and checking both of the variables, it becomes true. True false becomes false, true becomes true, true false becomes false, false and true becomes true, false becomes true, false becomes true, false becomes true. Repeat the same step for Q implying R. True truth, true false, false truth, false truth, true false, false truth, it becomes true, false becomes truth. After doing both of this part, we can actually just solve it directly now, as the question there are no components that is needed to be added. So here we can actually put symbols to indicate whether the symbol contains the components of the expression. So here the first component, P implies R, will connect with the N of Q implies R. So since 1 and 2, and since the connectivity is N, both of the true values of the first component and the second component must be true. So since here we can see is that both of them are true, it will become true. And for the other parts, if there is no if both of the values are not true, it will become false. So the result will be true false, true false, true false, and true true. After doing that, we need to check whether both of them are the same. And since the first and the second expression are the same truth values, we can now state the conclusion. So here, therefore, the compound statement would be contingency because the statement's two values contains both true and false. That is all for question 1. I will pass it to question 2.
Assalamualaikum madam, I'm Rai Dinesh bin Ridwan from RCS 1103C. Today I'll be talking about problem 4, which is my question in discrete maths or MAT 210. Okay, so this question is about topic in law of logic, which is we have to identify the equivalent identities. Okay, so let's go jump to the my question, which is question 2. Okay, so complete the steps as well as give the corresponding reasons in the simplification of the compound statement below using the law of logic. Okay, so we have to find the equivalent identities. Okay, so our question is in bracket P and R, or in bracket P and Q, or in bracket Q and in bracket again R and S, or in bracket R and not S. Okay, so in this question we have found the answer, which is commutative law, in which part the answer is in bracket Q and P. So from the upper question, in bracket P and Q, it will become in bracket Q and P. Yep, that's it. Okay, so the next one, from the upper question, we have found that that next answer is distributive law. From where? From in bracket R and S, or in bracket R and not S. It will become R and in bracket S or not S. That's the distributive law. Okay, so the next one is it will become inverse law. In which part? Okay, let's see. S or not S, it will become universal, which is T. So that's the inverse law. Okay, so number 4. Okay, number 4 is R or in bracket universal law, or we can conclude as T. Okay, that's the identity law. The equation R or in bracket T, it will become R. That is identity law. Okay, so the next one, in bracket Q and P, or in bracket Q. So that's the distributive law, which is the answer. The answer is in bracket P and R, or in bracket Q and in bracket P or R. So that's the distributive law. Okay, so the last one is from the question. Okay, we have found that in bracket P and R, okay, in bracket P and R, and in bracket P or R, that's his absorption law we have found. Yeah, that's absorption law. It will become in bracket P and R. Yep, so that's all from me, madam. Okay, thank you very much, madam.
My question that I am given to be answered is: use the rules of inference to show the argument below is valid. Okay. In this question, we're going to mostly be using validity of arguments using rules of inference. Okay. Now, see here we have a list. This is called the rules of inference. we have 12 types of rules, and each of them serve a very different objective for each hypothesis that we have in the question. Okay, now these rules are used to form arguments, to draw conclusions from other assertions, and these tautologies confirm the validity of an argument. Yes. Okay, next I'm going to show you how to solve that question. Okay, first we have how do we prove the conclusion is T. First we have P and Q, and then we have P if P, and then R and Q. We have number 3 R if R, then S or T, and finally we have not S. Okay, from here, which of these rules do you think we can use so we can form another hypothesis out of all of these others hypotheses? Okay, if you answered simplification, that is correct. Okay, from here we see that P and Q from rule number 6 simplification, if we have P and Q, we can simplify it to become just a P. Okay, next from here, what do you think? Okay, if you answered modus ponens, then you are correct. Then here we have modus ponens, which we use from hypothesis 2 and 5. See, modus ponens from the first rule. If P then Q, then we have another hypothesis which is just P. Then we can fuse it using the rule of modus ponens, and then we have a Q. Or in this condition we have P 2 if P, then R or Q, R and Q, and then we have 5 which is just P. So if we look at the rules, they look just the same, but the difference is that Q is basically changed by R and Q. So in a way it's the same, but yeah, the difference is the variable there that we have. Okay, next we also do simplification. That's right, we use number 6. So you can see that R and Q is just like the same as the simplification P and Q. So in a way we can just go directly through simplification and consider it as an R. Next, we also use a modus ponens for 3 and 7. So for 3 and 7, R if R, then S or T, and also R, we could get, using modus ponens, we could get S or T, which is basically the same just like number 6 which we used both hypotheses number 2 and 5, but now we use number 3 and 7. Okay, and finally, yes, we can get T, the conclusion. Now, disjunctive syllogism. This is rule number 4, where if there are two hypotheses P and Q, and also not P, we can directly straight up go get Q. I'm sorry. I mean, we can get Q if there are two hypotheses which are P or Q and not P. So if we do the same for 4 and 8, which is not S, and S or T, yeah, we could consider it quite the same, and in the end we can have T, which is considered the conclusion. Yeah, so that ends my presentation for question number 3.
To summarize what we have learned is that logic is the study of reasoning and arguments, examining the validity of inductive arguments and recognizing flaws in reasoning. It is crucial for critical thinking and effective communication. Actually, it is always used in our daily lives in many situations. We can say, for an example, is that if a customer wants to buy a fried chicken or a nasi lemak. Therefore, fundamentals of logic is very important to have its existence as a subject to learn, because of how its usage is used in many people's daily lives. So that is from us. Thank you.